our homework assignment from lesson 10 in our third unit, dealing with the first time we're seeing imaginary numbers. First question says, select all the true statements. A says the square root of -1 is an imaginary number. This is definitely true. That was kind of the whole idea of this lesson, is we're seeing that we can't take the square root of -1 and we're calling this an imaginary number. B, there are no real numbers that satisfy the equation x equals -1. Well, that's same exact idea. We had to create these imaginary numbers to produce what is a solution to an equation that looks like this. C says because the square root of -1 is imaginary, no one does math with it. That is a lie. Square roots of -1, these imaginary numbers come up all over the place in higher level math. Again, we have to kind of keep as many doors open for you guys as possible. In this case, learning about imaginary numbers, one of the very first things that come to mind for me is the applications with electricity. But again, we can't learn about those applications until we understand imaginary numbers first. D says the equation x squared equals -1 has real solutions. Well, that's not true as far as square root both sides. How we get the square root of -1. And E says the square root of -1 is equal to -1 because -1 times -1 is equal to -1. Well, there's a whole bunch of bad statements in there. -1 times -1 is not -1. -1 times -1 is +1. So, question 1, we should have A and B circled. 2 says plot the number line, each number on the real number line, or explain why the number is not on the real number line. So I'm going to go ahead and plot the square root of 4. Square root of 4 is just 2. So I'm going to go to my 2 on my real number line and plot 2. B is the square root of -4. Excuse me, I said that wrong. Negative of the square root of 4, which is just -2. That is also on the number line, so far, so good. C, I cannot do anything with this. Very shortly, we're going to learn how to simplify this. This is actually going to simplify into 2i. This is not on our imaginary number line, or our real number line. We have to be producing an imaginary number line. I cannot plot that. Square root of 8. Well, I would normally take the square root of 8 and I would simplify it. And I would split this into 2 times 4, but I know the square root of 4 is 2. So generally speaking, I would never even see this written like this. I should see this written as 2 square roots of 2. But either way, I can tell that this number is a little bit less than 3. The reason being is because I know that the square root of 9 is 3, and this is the square root of 8. So it's going to be somewhere like right in here. Don't know for sure, but it's going to be roughly there. When we're plotting these irrational numbers on the real number line, you kind of have to take a ballpark stab at it, and that's what we did here. So it's the same thing for the next one. I would end up having -2 square roots of 2, which would be approximately negative, I don't know, a little bit less than 3, so somewhere in here. And I'm going to call that E. And then F, I cannot do. Again, in the very near future, we're going to learn that we can actually simplify this thing. And this thing would simplify to 2 times the square root of 2i, but we are not to that point yet. So there are the numbers I could plot on the number line. I plotted A, B, D, and E. Question 3. Which value is the closest to 10 raised to the -1/2 power? Well, if I have a negative exponent, I have to take that negative exponent and reciprocate it, which means this is the same thing as 1 over 10 to the 1/2 power. And we need to recognize that the 10 to the 1/2 power is the same thing as the square root of 10. So this is really 1 over the square root of 10, roughly. We know that the square root of 10 is going to be roughly a little bit more than 3, so this is approximately 1/3, which looks like C. 5 says, which is a solution to the equation, and I have a little radical equation here. It says the square root of 6 minus x is plus 5 is equal to 10. Multiple ways I could do this. I could just plug the numbers in to see if they work because it's multiple choice. Or I could actually take this and solve the equation. That's what I'm going to do. I'm going to follow my order of operations backwards, so I'm going to undo adding and subtracting first. So now I get the square root of 6 minus x is equal to 5. To undo square rooting, I square. As I square both sides, I get 6 minus x is equal to 25. Subtract 6 from both sides, negative x is equal to 19. Divide both sides by -1, I get x is equal to -19. So as I come over here, I check to see I have that -19. Because it's a radical equation, I should just double check to make sure this works because there are times where I can't take the square root of a number. If I plug in -19, I'm going to get this thing to check out. -19 6 minus a negative 19 is 25, the square root of 25 is 5, and 5 plus 5 is 10, so that checks out. 6 says select all equations for which the square root of 64, for which negative 64 is a solution. So in each one of these, I would just go ahead and solve each one of these real quickly to undo square root. We square, and if I were to square 8, I end up getting 64. So I would get x is equal to 64 in this case, which means no dice. Couldn't plug a negative 64 in there, I'd be getting an imaginary number. Same thing over here. If I were to square both sides, I would end up getting x is equal to 64. However, I have to be really, really careful with this because if I were to plug in negative 64, I'd be able to tell I get imaginary right away. So, wrong. Next one, the cube root of x, which means I would have to undo by cubing. Well, that would mean, let's see here, 4 cubed, 4 times 4 is 16 times 4 is 64, which means another no-go. Next one, cube both sides. Negative 4 times negative 4 times negative 4 is negative 64, so we finally have a winner. D would work out. Next one, I would undo the multiplying by negative 1 by dividing by negative 1. And if I were to do that, I get the square root of x is equal to negative 8. And now when I square both sides, we can tell that this is pretty much what we had earlier. I get x is equal to 64, so E doesn't work. And then in this case, if I were to square both sides, I end up getting negative x is equal to 64, divide by negative 1, and we get x is equal to negative 64. So we do actually have two options in this case. We have D and we have F. And there's your homework assignment from lesson 10, the first lesson in which we started looking at imaginary numbers.